Hi guys, in this video we are going to see about MongoDB. MongoDB is an open source NoSQL database management program. NoSQL means not only SQL is used as an alternative to traditional relational databases. NoSQL databases are quite useful for working with large sets of distributed data. MongoDB is a tool that can manage document-oriented information, store or retrieve information. MongoDB is used for high volume data storage, helping organizations store large amounts of data while still performing rapidly. Organizations also use MongoDB for its ad hoc queries, indexing, load balancing, aggregation, server-side JavaScript execution, and other features. SQL Structured Query Language is a standardized programming language that is used to manage relational databases. SQL normalizes data as schemas and tables, and every table has a fixed structure. SQL is a tool for organizing, managing, and retrieving archived data from a computer database. Instead of using tables and rows as in relational databases, as a NoSQL database, the MongoDB architecture is made up of collections and documents. Documents are made up of key value pairs, MongoDB's basic unit of data. Collections, the equivalent of SQL tables, contain document sets. MongoDB offers support for many programming languages such as C, C++, C Sharp, Go, Java, Python, Ruby, and Swift. Now we see about introduction to databases. Databases are organized collection of structured data that are designed for efficient storage, retrieval, and management of information. They serve as a central repository for storing, organizing, and accessing data in various applications. MongoDB is a popular NoSQL database system that is important in modern applications for several reasons. The reasons are scalability. MongoDB is designed to scale horizontally, making it suitable for handling large volumes of data and high traffic applications. It can distribute data across multiple servers for improved performance. Flexibility. MongoDB uses a flexible schema model, allowing you to store and query data without a fixed structure. This is particularly useful for applications with evolving data requirements. Document oriented. MongoDB stores data in a format called BSON, binary JSON, which is a more natural representation of data for many modern applications, especially those that work with JavaScript. High performance. MongoDB provides fast data access through features like indexing and support for complex queries. It can also handle geospatial data efficiently. Horizontal partitioning. MongoDB supports sharding, which enables data distribution across multiple servers or clusters. This helps maintain performance as data grows. Adapting to agile development. MongoDB aligns well with agile development practices due to its schema flexibility and the ability to accommodate changes in the data model as the application evolves. What is MongoDB? MongoDB is a widely used open source document oriented NoSQL database management system. It falls under the category of NoSQL databases, which are designed to handle unstructured or semi-structured data more flexing than traditional relational databases. MongoDB is known for its scalability, performance, and flexibility, and it is commonly used in a variety of modern applications. Key features of MongoDB includes document oriented. MongoDB stores data in BSON binary JSON documents which are similar to JSON objects. Each document can have a different structure, making it highly flexible for storing various types of data. No fixed schema. Unlike traditional relational databases, MongoDB does not require a predefined schema. This means you can add or modify fields in your documents without affecting the entire database. Scalability. MongoDB is designed for horizontal scalability. It can distribute data across multiple servers or clusters, allowing applications to handle large volumes of data and high traffic. High performance. MongoDB offers fast data access through features like indexing, native support for geospatial data, and the ability to run complex queries. Aggregation framework. It includes a powerful aggregation framework for data analysis and transformation, allowing you to perform complex operations on data within the database. Ad hoc queries. MongoDB supports dynamic ad hoc queries, making it well suited for applications with evolving data requirements. Community and the ecosystem. MongoDB has a large and active community providing extensive resources, support, and a wide range of drivers and libraries for integration with various programming languages and frameworks. MongoDB is commonly used in web applications, content management systems, real-time analytics, mobile app development, and other scenarios where flexibility and scalability are important. It is a popular choice for developers looking to manage and access data efficiently in today's data-intensive applications. MongoDB uses relational databases. Relational databases. Structured data. Relational databases store data in a tables with fixed schemas where each row represents a record and each column represents a specific attribute. This structured approach enforces data integrity. SQL language. Relational databases use SQL for querying and manipulation. SQL provides powerful capabilities for complex queries, joins, and transactions. ACID compliance. ACID stands for atomicity, consistency, isolation, and durability. Relational databases are typically ACID compliant, ensuring strong data consistency and reliability. Scalability. While relational databases can scale vertically, adding more resources to a single server, it can be challenging to scale them horizontally for high traffic or large datasets. Use cases. Relational databases are often used in applications where data consistency, integrity, and complex querying are essential, such as financial systems, e-commerce, and traditional business applications. MongoDB NoSQL document oriented. MongoDB stores data in flexible, semi-structured documents JSON format. Each document can have a different structure, allowing for more dynamic data models. No fixed schema. MongoDB does not require a predefined schema, allowing you to add or change fields in documents without affecting the entire database. This flexibility is suitable for rapidly evolving data. No SQL language. MongoDB uses a query language that is not SQL, but it is designed to work with JSON-like documents. It supports querying, indexing, and the aggregation features. Scalability. MongoDB is designed for horizontal scalability and can distribute data across multiple servers or clusters. It is well suited for handling large volumes of data and high traffic. Use cases. MongoDB is commonly used in applications that require flexibility, scalability, and a high-speed data access, such as content management systems, real-time analytics, mobile apps, and the IoT platforms. Choosing between the two. The choice between MongoDB and relational databases depends on your specific application requirements. Use a relational database when you need strong data consistency, complex joins, and transactions, and your data model is well defined and unlikely to change frequently. Use MongoDB when you need flexibility, scalability, and quick data access in a dynamic environment where the data structure may evolve over time, or when dealing with large volumes of unstructured or semi-structured data. Key features of MongoDB. Document oriented. MongoDB is document oriented database, which means it stores data in JSON documents. Each document can have a different structure, making it highly flexible and suitable for storing semi-structured or unstructured data. No schema constraints. Unlike traditional relational databases, MongoDB does not require a fixed schema. You can add or modify fields in documents at any time without affecting other documents in the same collection. Scalability. MongoDB is designed for a horizontal scalability. It can distribute data across multiple servers or clusters, allowing applications to handle large volumes of data and high traffic. Backup and restore. MongoDB provides tools for data backup and restoration to prevent data loss and ensure disaster recovery. High performance. MongoDB provides fast data access through features like indexing, native support for geospatial data, and efficient query optimization. It's designed for real-time analytics and fast data retrieval. Aggregation framework. MongoDB includes a powerful aggregation framework for data analysis and transformation. It allows you to perform complex operations on data within the database, including filtering, grouping, and sorting. Ad hoc queries. MongoDB supports dynamic ad hoc queries, making it well suited for applications with evolving data requirements. You can query data using a query language similar to JSON. Replication. MongoDB offers data redundancy and high availability through replica sets. Data is automatically replicated to multiple servers to ensure fault tolerance and data durability. Atomic operations. MongoDB provides atomic operations on a per document level, ensuring data consistency and eliminating race conditions. Geospatial capabilities. MongoDB has built-in support for geospatial data and queries, making it a good choice for location-based applications. Security. MongoDB includes security features such as authentication, role-based access control, and encryption to protect your data. Data validation. You can define custom data validation rules to ensure data integrity and consistency. Change streams. MongoDB supports change streams, allowing real-time monitoring of changes to data, which is useful for building reactive applications. Document structure. In MongoDB, a document is the basic unit of data storage and retrieval. It is similar to a row in a relational database table, but unlike traditional relational databases, MongoDB is a NoSQL database that stores data in a more flexible, semi-structured format. Documents in MongoDB are typically represented in binary JSON format, a binary encoder serialization of JSON data. Key characteristics of documents in MongoDB. JSON format. MongoDB stores data in JSON, which is a binary representation of JSON. This format supports various data types including strings, numbers, dates, arrays, and nested documents, making it suitable for handling complex structured or semi-structured data. Flexible schema. Unlike relational databases that require a predefined schema, MongoDB allows documents within a collection to have varying structures. This flexibility means that different documents in the same collection can have different fields, making it easier to adapt to changing data requirements. Indexing. MongoDB supports indexing to improve query performance. You can create indexes on specific fields within documents to speed up search and retrieval operations. Fields. A document consists of one or more fields, each of which has a name and a value. The value can be of different data types and these fields can be nested, allowing for the representation of hierarchical or nested data structures. Collection. In MongoDB, documents are organized into collections which are analogous to tables in relational databases. Each document in a collection can have a different structure, but they are typically related by a common purpose or context. No fixed schema. MongoDB collections don't enforce a fixed schema on documents, which means that you can insert new fields or removing existing fields from documents without affecting other documents in the same collection. This flexibility is especially useful when dealing with involving data requirements. Atomicity. Individual document operations in MongoDB are atomic, meaning that they succeed entirely or fail completely. This ensures data consistency and reliability. Querying. MongoDB provides a rich set of query operators and methods for retrieving and manipulating documents. You can search for documents based on various criteria such as field values, text search, and geospatial data. The document-oriented data model of MongoDB is well suited for applications with evolving data requirements, large datasets, and semi-structured or unstructured data. It provides the flexibility to adapt to changing needs and allows for efficient storage and retrieval of data. Data modeling in MongoDB. Data modeling in MongoDB is the process of designing the structure of your data to meet the specific needs and requirements of your application. MongoDB is a NoSQL database and it uses a document-oriented data model which is different from the tabular relational model of transitional and SQL databases. When modeling data in MongoDB, you should consider the following key principles and practices. Understand your application's requirements. Start by thoroughly understanding your application's requirements and how the data will be used. Identify the types of data you need to store, how it will be accessed, and any performance considerations. Define your collections. In MongoDB, data is organized into collections which are similar to tables in SQL databases. Each collection holds a set of documents with a common purpose or context. Define collections that logically group related data. Flexible schema design. MongoDB allows for a flexible schema, meaning that documents in the same collection can have different structures. This flexibility is useful for accommodating changes in your data requirements over time. You can add, remove, or modify fields in documents as needed. Normalization versus embedding. When modeling relationships between data, you have two primary options: normalization and embedding. The first one is normalization. This involves creating separate collections for related data and linking them through references, while embedding involves nesting related data within a single document. The choice depends on factors like data access patterns and data size. Indexes. Define indexes on fields that are frequently queried to improve query performance. MongoDB supports various types of indexes, including single field, compound, and text indexes. Consider sharding. For large-scale applications with high data volumes, consider sharding your data. Sharding involves distributing your data across multiple servers or nodes, which can improve scalability and performance. Backup and disaster recovery. Develop a strategy for regular backups and disaster recovery. MongoDB provides tools and options for creating and restoring backups. Monitoring and performance tuning. Continuously monitor the performance of your MongoDB database and make adjustments as needed to optimize query performance and resource utilization. Security considerations: implement proper access control and authentication mechanisms to ensure the security of your MongoDB. MongoDB offers role-based access control and authentication options. Querying MongoDB. Connect to the database. Before you can query data in MongoDB, you need to establish a connection to the database using a MongoDB client or driver. Common client libraries are available for various programming languages such as Python, Java, Node.js, and more. Select the collection. Choose the collection from which you want to retrieve data. Collections in MongoDB are similar to tables in SQL databases and hold documents with related data. Basic queries. MongoDB supports a wide range of BigQuery operators to filter and retrieve data. MongoDB querying documents using find function. Find method. In MongoDB, find function method is used to select documents in a collection and return a cursor to the selected documents. Find and modify. The find and modify command modifies and returns a single document by default. The returned document does not include the modifications made on the update. To return the document with the modifications made on the update, use the new option. Find one. The find one method finds and returns one document that matches the given selection criteria. If multiple documents satisfy the given query expression, then this method will return the first document according to the natural order, which reflects the order of documents on the disk. If no document matches the selection criteria, then this method will return null. It takes two parameters. First one is the query criteria and the other is optional. Find one and delete. The find one and delete method deletes a single document based on the selection criteria from the collection. It deletes the first document from the collection that matches the given filtered query expression. It takes 5 parameters. The first parameter is the selection criteria and the others are optional. Find one and replace. The find one and the replace method replace the first matched document based on the given selection criteria. By default, this method returns the original document. To return the replacement document, set the value of the return new document option to true. It takes 8 parameters. The first parameter is selection criteria and the second parameter is the replacement document and the others are optional. Using this method, you can also replace embedded documents. You can also use the method in multi-document transactions. Find one and update. The find one and update method updates the first matched document in the collection that matches the selection criteria. If more than one document matches the selection criteria, then it updates only the first matched document. When we update the document, the value of the ID field remains unchanged. This method will return the original document, but if we want to return the parameter to true, it takes 3 parameters. The first one is selection criteria, the second one is the new date to be updated, and the third remaining are optional. Because we using this method, you can also replace embedded documents. You can also use the method in multi-document transactions. Use cases in MongoDB. Real-world use cases for MongoDB. Content management systems. MongoDB can be used to store and manage content for websites, blogs, and digital publishing platforms. Its flexible schema is helpful when dealing with various content types and user-generated content. E-commerce platforms. MongoDB can power e-commerce websites by efficiently storing product catalogs, customer profiles, and order data. Its ability to handle large amounts of data and support complex queries, user profiles, and their personalizations. Many applications use MongoDB to store user profiles, allowing for personalized experiences. MongoDB document oriented data model is well suited for this use case. Catalogs and the product information. MongoDB is used in product catalogs for various industries including retail, automotive, and the real estate. It can store detailed product information, images, and specifications in a flexible manner. Log and event data. MongoDB is excellent for storing and analyzing log data, event data, and sensor data. Its ability to handle large volumes of data with low latency makes it suitable for monitoring and analytics applications. Mobile applications. MongoDB is a popular choice for mobile app backends because it can store user data, app related content, and supports real time synchronization across devices. Social media platforms. Social networks and social media analytics platforms often use MongoDB to store user profiles, post comments, and other social interactions. IoT. IoT stands for Internet of Things. MongoDB can handle the vast amount of data generated by IoT devices. It is used to store sensor data, monitor device health, and analyze trends. Gaming. Online and mobile games use MongoDB to store player profiles, game state, leaderboards, and in-game transactions. MongoDB's real-time capabilities are valuable for multiplayer and online games. Content Delivery Networks (CDNs). Content delivery networks use MongoDB to manage and distribute content efficiently. It can store metadata about content, user access rights, and the access logs. Healthcare systems. MongoDB is employed in healthcare systems for storing patient records, medical data, and healthcare related information. Its flexibility is crucial for accommodating various data types. Financial services. MongoDB is used in financial applications for customer data, transaction records, fraud reduction, and risk analysis. It is high availability and scalability support mission critical applications. Conclusion. Now we understanding the pros and cons of MongoDB. It uses both document-oriented data model and an unstructured query language. It provides scalability and flexibility for developers to easily use and learn the tool. It is built on a scale-out architecture that allows developers to build applications using agile methods. It is popular among developers as it helps them build internet and business applications. MongoDB has its pros and cons that need to be addressed. Business should understand the pros that MongoDB offers and the cons that it possesses. The pros and cons for businesses in using MongoDB. Companies and development teams of all sizes and industries recommended MongoDB regardless of its various pros and cons. It provides solutions for businesses in IoT, gaming, logistics, and then banking, e-commerce, content management, etc. It seems that MongoDB's pros are such that its cons can be overlooked. Advantages of MongoDB performance levels. MongoDB stores most of the data in the RAM. It allows a quicker performance while executing queries. High speed and higher availability. It is a document based database solution. It has attributes like replication and the GridFS. Its attributes allow an increase in data availability. It is also easy to access documents using indexing. It performs 100 times faster than other relational databases and provides high performance. Conclusion. However, MongoDB may not be the best choice for every scenario. It's essential to carefully consider your application specific requirements, including data structure, access patterns, and scalability needs before choosing MongoDB or another database technology. Additionally, like any database system, proper design, indexing, and maintenance are crucial to achieving optimal performance and data consistency. In the rapidly evolving landscape of data storage and management, MongoDB has established itself as a valuable tool for many modern applications. Its combination of flexibility and scalability, along with features like horizontal scaling and geospatial capabilities, positions it as a strong contender in the world of NoSQL databases. Whether MongoDB is the right fit for your project depends on your unique needs and the nature of your data.